Hello guys, my name is Shubham Admane. Welcome to my channel TedNetworking. So today we are going to discuss about headers, TCP header, UDP header, IP header, and Ethernet header. So first is TCP, second one is UDP, third one is IP, and fourth one is Ethernet. So TCP header comes in transport layer. Same for UDP. And Ethernet comes in data link. So let's start with TCP. TCP header, transmission control protocol. So this is your TCP header. So in source port, it's have 16-bit value. Same for destination 4. It have 16-bit value. And next one is sequence number. Sequence number is used for when the TCP packet is sent for a sync. Then that time it's use sequence number, and whenever the acknowledgements come, that time acknowledgement number use. So the next field is header length. Header length means it's contain the information of total length of TCP. And second one is reserve. Reserve is used for is not used. It's a reserve bit. And next one is flag. So there are 8 flags. CWR, that is congestion window reduce. Second one is ECN, that is explicit congestion notification. Third one is urgent. Next one is acknowledge, then push, then reset, then sync, then finish. So there are 8 flags in TCP header. So next one is window size. Let's have 16-bit value. In window size, there are two flow control comes. First one is wait and send, and second one is windowing. So the next field is checksum. that is a CRC, cyclic redundancy check. It's used for error detection. And next field is urgent pointer. It's also 16-bit. It's contain the sequence number which is urgently required. And next field is option. It's an optional field. So if you ignore this option field, if you're not using option, then your header size is 20 bytes. If you use this option field, then your header size become and shift from 20 to 24. So how to calculate this header size? So this is 32 bit. It's mean 4 byte, 4 byte for first, then 4 byte for second, then again 4 bytes for third, then for fourth, then for fifth. In this way, it's become 20 bytes. Same if you use option field, then 20 plus 4 is equal to 24 bytes. So let's talk about windowing. So when window size set to 1, then sender send one packet. When the receiver receive that, it's acknowledged with number 1. Then again sender send second packet. Then receiver receive and send acknowledge 2. Suppose if you set your window size to 3, then what will happen? Sender send 3 packet, then receiver give acknowledge, then receiver give acknowledge with number 4. Then again sender send 3 packet, then same process happen again and again. So this is windowing. Suppose while sending packet, one packet lost. See here, packet number 5 lost. So receiver send acknowledgement 5, then sender again send that packet to receiver. Then next package goes on. In this way windowing perform. So let's talk about UDP header. So this is how your UDP header look. So it's 8 bytes because of 32 bit, and next one is 32 bit. So total is 8 bytes. So in this UDP header, first is source port which have the 16 bit, and next one is destination port. It also have 16-bit value. So next field is length. So this is the header length of TCP, of UDP header, and next field is checksum. So it's a checksum. Here error detection perform. So it's a small header compared to TCP. So what is the difference between in TCP and UDP? First point is three-way handshake. Second point is connection oriented. Third point is reliable. Fourth point is send acknowledgement. And fifth point is slow. port use 6. Let's talk about UDP. So first point is no three-way handshake, connectionless, unreliable, no acknowledgement, fast as compared to TCP, and port use 17. So in TCP and UDP, here are three-way handshake performed, and in UDP there is no acknowledgement in UDP. That's why when packet sent from one destination, from one source to another destination, then if the packet gets lost, then in UDP there is no way to tell sender that the packet is lost and send it again. So let's move to IP header. But before that, let's let's see how the source port and destination port work. Source port and destination port. 16 bit. 16 bit. So TCP use services as such as DNS 53, Telnet 23, SSH 22, FTP 20, 21, SMTP 25, HTTP 80, and HTTPS 443. So UDP use DNS 53, TFTP 69, DSCP 68 and 69, sorry, 67 and 68, SNMP 161. Suppose you are using any one of these services, so how the source port and destination port field use? Suppose you are using telnet service. Telnet. So source IP, suppose 12.1, destination IP 12.2. So source port is random that is above 1024, suppose 1028, and destination port is equal to 23. So the destination port shows the which type of service you are using. So if you are using telnet service, then it shows destination port is equal to 23. So in this way your source port and destination port work. So let's move to our IP header. So this is your IP header and it's of 20 byte. So this is your IP header. It's from 20 byte to 60 byte. So I will tell you later how it's when it's 20 byte and when it's 60 byte. So the first field is version. In this, it shows whether it's use IPv4 or IPv6. So how the header tell whether it's IPv4 or 6. So so version field is of 4 bits. So 8, 4, 2, 1 binary. So 0, 1, 0, 0 equal to 4. It means we are using IPv4. If it's 0, 1, 1, 0, then 6. So total is 4 plus 2 is 6. Then we are using IPv6. So what is IPv4, IPv6 version? I will tell you later when we are learning IP addressing. So the next field is header length. It's also 4 bit, and it shows the header size whether it is 20 bytes or 60 byte. So how it's and how d- so how it's calculate 20 byte or 60 byte. Header length same as, so when it's 1, 1, 1, 1 equal to 15. So when the value is 15, then it's multiply by 4, then it's become 60. So when it's 5, then again multiply by 4, so it's become 20. In this way, the header length vary from 20 to 60 byte. When you use option field, that time it's become 60 byte. So next field is priority and type of service. Type of service, or you can call TOS. So it's basically a DSCP service. So for CCNA level, it's not related to you. Then next field is total length. So total length means header length plus data length. So suppose your header length is 60, then data link is 1440, so total is 1500. So next field is, let's talk about protocol field. So it's contain the information of upper layer, such as which type of service you are using, TCP or UDP. Suppose if you are using TCP, then it shows the number 6, and if you are using UDP, then it shows the number 17. So next field is TTL, that is time to live. Is define the age or lifespan of packet. In case of router, TTL is hop count. Hop count is equal to number of routers. By default, TTL value is 255. When the packet cross one router to another router, then TTL decrease by 1. So when the TTL become 0, the packet get expire, or you can say drop. So TTL value is 8 bit. That means 2 to the power 8 is equal to 256. That's why it's a range from 0 to 255. That's why TTL is equal to 255. So let's talk about fragmentation. To divide a large segment into smaller fragment is known as fragmentation. So the size of fragmentation is depend on interface, that is the size of MTU. MTU means maximum transmission unit. So for Ethernet, it's 1500. So the next field is identification, or you can say identifier, to identify the fragments. So when you fragment your segment into smaller fragments, then how will you identify which segment is which fragment is first, second, or third, or whatever? So for that, we use identification field. Next field is flag. So it's a 3 bit. That means it's contain three flag. That is first one is reserve flag, second one is don't fragment, and third one is more fragment flag. So reserve flag always set to 0. Obviously, it's a reserve for future use. So next is don't fragment. It's used for telling that don't fragment when it's one, then it's on. So next is more fragment. So when it's on, that's mean more fragment are coming. If it's zero, then no more fragment is present. So next field is source IP address. So it's a 32-bit. Here your source IP present, and in destination IP address your destination IP present. This is the next field is option. It's a option. It's a optional field. Here we can use a strict, loose, record, timestamp. These are the extra function uh, that's not used in our CCNA level. So we are not going to discuss about that. So the next is data link header. So this is your Ethernet header. So it's contain preamble. So preamble means it's contain the it's a 7-bit value in order to in a 101010 form for synchronization between sender and receiver. It's sent by 5 megahertz. So so the next is SFD, start frame delineator. So it's tell the receiver about from where the original frame is going to start. So when the last bit become one, then it's tell the original data going from this original data start. So this is your destination MAC. This is your source MAC field. It's of 6 byte each. The next field is type. It's of 2 byte. It's contain the information of upper layer protocol such as IP. And the next field is FCS, that is frame check sequence, which is of 4 byte. It's used for error detection, and this is your data field. So in our next video, we are going to learn about MAC address and IP addressing. So that's it for today. If you like my video, please like it, share it, and subscribe it. Thank you.